Hello, right, here we go with what we can call is the lesson 13. Oops, lesson 13, and it's all about handling data. Okay, I'm going to split this up into two parts because you remember we did something to do with scattergrams. Let's have a, okay, I think the volume is okay. Right, okay, so handling data. The first thing to do was if we have this, a row of numbers, it's called a data set. Okay, and the first thing we're going to find is the range. Now the range is the difference between the largest and the smallest. Okay, so this one we've got the largest is 11, the smallest is 2, so the difference there will be equal to 9. Now if you have negative numbers, as in temperature, things like this, -4, -3, 0, 1, 2 and 6, the range of this is a little different to work out. So this one is going to be the difference between -4 and 6. So if we do a temperature thing here, so we've got -4 and we've got 6 at the top. So we need a difference between all of those. So you go 6 down and 4 down, which equals 10. So in actual fact, what we're doing is 4 add 6, yeah, equals 10. So be wary of negative numbers when you're doing the range. The next thing we did was again from a 2, 3, 6, 9, 12, 15. We're going to work out, let's have another 9 in there, yeah? So we're going to work out what's called the mode. And the mode is the most common. It's the number that appears the most times. And yeah, I put an extra 9 in there. So 9 appears twice and everything else appears once. So the mode in here is 9. Now, if we stick another 15 on the end, then 15 and 9 both appear twice. So now the mode becomes 9 and 15. Now, if we've got 2, 3, 4, 5, 6, 7, and 8, and no number appears more than any other, then it's said to be no mode. Okay, right, no mode for that one. Now, next one to do is the median. The median is the middle value. It's not the middle number because there might not be a middle number, but it's the middle value. So let's go 2, 3, 4, 8, 12, 15 and 16. Now you can see the middle one is 8, but we'll prove it mathematically. So first of all, we have to remember this formula, which is n plus 1 divided by 2. Now n is the number of digits that we've got. 1, 2, 3, 4, 5, 6, 7. So we've got 7 plus 1 divided by 2, 8 divided by 2 equals 4. Now that doesn't tell you the median itself, it just tells you the position of the median. So what we do is we count 4 from the end. 1, 2, 3, 4. Or from the other end, 1, 2, 3, 4. And there is the number that is the median. So the median in this case is equal to 8. Now, if there is no number in the middle, we're still finding the median. 2, 4, 8, 10, 14, 20, 23 and 25. Now you'll see that these are in ascending order. In order to find the range and the mode, they can be all over the place, but here we've got to have them in ascending order so we can find the middle value. So again, we do n plus 1 divided by 2, and there's 8 numbers. 8 plus 1 divided by 2, 9 divided by 2 is 4.5. The position. Okay, now let's count in 4.5 from the end. 1, 2, 3, 4.5. It's in between 10 and 14. So we've got to find the midpoint of 10 and 14. Now, this is fairly obvious that it's 12, but in case the numbers are awkward or they're decimals and you don't quite know where the middle is, we do it this way. We add the two together that surround the midpoint, and we divide by 2, which is 24 divided by 2, which equals 12. And there is the median. So what can we do next? What can we do next? Right, the next thing to do is the mean. Now for this, we need to add every thing together and divide by how many there are. Okay, for example, 2, 4, 6, 8, 10 and 20. Right, there's 1, 2, 3, 4, 5, 6. So we're going to divide by 6. Now, we need to add all this lot up together. So we've got 20, 30, 38, 44, 48, 50. 50 divided by 6. Oh, use a calculator for that. Okay, so 50 divided by 6 equals 8.3. 8.3. In this case, it's recurring, but in a proper exam question, they give you a proper number. So that's how you find the mean. You just add them all up together and divide by how many there are. Now, whether I can view, if we could have view, just trying to make this a bit bigger so I can see, zoom in, zoom to. Right, so let's put some words into these. So we've got 4 sacks of potatoes. 4 sacks of potatoes, and they have a mean weight of 12.5 kilograms. So what's the total? The total of the 4 sacks, the total. So before we added everything up and divided by how many there are to give us the mean. We know what the mean is, and we know how many there are. So what we've got to find is the total. So I'll just whiz up there. We're going to do this in reverse, because that would be 8.3 times 6 would be equal to 50. So we're going to do it the other way around. So we've got 12.5 is the mean, times the 4 sacks is, hang on, 2 of them are 20, oh, it's 50, isn't it? Yeah, 50 kilograms. So you're working the other way around. Now, if you have 6 sacks and the mean is 18 kilograms, you would go for the total, you'd go 18 times 6 is 108 kilograms. So we're going to add another sack, which is 10 kilograms. So we're going to end up with 7 sacks altogether. So what's the mean of 7 sacks? Now we know the total of the 6 is 108. So we need the 108. We're going to add the 10, which gives us 118 kilograms. Now to find the mean for the 7 sacks, we do the 118 divided by 7 now, which is 16.86 kilograms. So we added a sack that was less than the original mean, though therefore it drags the mean down a bit. Let's have another look at another one. Right, okay. Then we did this and we got more typical of a functional GCSE question. A team has 18 players, have a mean of 1.6 meters, so they're tall. Yeah, 1.6 meters tall. What's the total of all of that lot? So all we need to do is 8 times 1.6, which is 12.8 meters. Alright, another joins. Who is 1.7 meters tall. What happens to the mean? What happens? You don't have to work this out. What happens to the mean? Now, if the mean is 1.6 and a person that is 1.7 joins, this means the mean average goes up. The mean goes up. Yeah. Okay, and what do we do? Right, now we did favourite question about the zoo. So there are 8 penguins, and you'll find this that they make the questions a bit convoluted. 8 penguins, and their heights are as follows: 41, 43, 44, their heights in centimetres, 44, 47, 48, 50 and 51. Okay, now to escape, and we've got to work out if the mean of the remaining 6 is 44.5, who escaped. 2 of them escaped, but which ones were it? Which ones was it? Or who was it? Now, I'm going to do this. Now, let's find the total height of all the 8 penguins. So we need to add up all of these. Yeah, so all 8 penguins all add up to 368 centimeters. Now the 6 penguins, their total height is 44.5 times 6, which is 267 centimetres. Now the difference between these two numbers will give us a clue to who escaped. So 368 minus 267 equals 101. Now there are only two penguins that add together to make 101, which is this one and this one. Yeah, so the escapees are 50 and 51. Then we went on to do a little bit of scatter things, and then we got into frequency tables. Right. So a bit of background. we've dealt with data sets, just a row of numbers. Yeah, done that. Now, information can be either discrete or continuous. This makes a difference when we're trying to work out the mean mode mean mode, median, and the other one, the range, in these two different kinds of information. Now, the discrete information is where you count. So you can count colours like red, blue. How many coloured buttons have you got? Red, blue, green, black. You count them. So if you were doing a table, you'd say we had 2 red, 3 blue, 4 green and 6 black, and you'd make yourself a little table out of that. And we're counting. There is no ambiguity. There's no crossover between which is red and which is blue. You're either red or blue. If you're a bit halfway, you're not ignored. You're nothing to do with it. Yeah. So you either get that, or you get continuous data, which you measure. And when you measure data, it's usually length, or weight, something like that. Yeah, length or weight. Whereas if you start to make a table of, say, people's heights, and you think, oh, the first person is 1.8 meters, second person is 1.81, third person is 1.806, 1.8072, yeah, and depending on how accurate you can be, you could find out that the heights of whatever you're measuring, no two are exactly the same. So you'd have a table that did this, and you'd end up with one in each of them, and it would be hopeless. So what you need to do is you need to group the data together. And I'll show you how that's done after we do some calculations on the what's called a frequency table. Now the word frequency for our purposes just means how often. I'm going to wipe that out because I can't see that myself, so I don't expect anybody else to be able to see that. So how often or how many? Yeah. So if we were seeing different coloured cars whiz up down the motorway, we would see 2. So it's sort of how often they went past, how often a red car happened, or how many red cars did we see altogether. And this will be, we'll discover the name of that in a minute. So let's have a look at this. Let's have a look at a frequency table. Now, so we're doing a survey, and we're seeing how many cups of tea people drink. So we got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so we've got the choice of 0, 1, 2, 3 or 4. So we're going to ask people how many cups of tea they drink, and they are going to give us the answer: I drink 2, I drink 3, etc. Now this column is called the frequency, and you might have to fill this in from a chart, a table, no, or it might be just given for you. So we'll just do this: 8, 6, 5, 2 and 1. And this column is in the question, but it's blank. We don't know what that is yet. So we're going to find out what the range. Now this is the range of the cups, not the range of the people. These people in the frequency column are the people that responded to our survey. 8 people said they drink no cups. 2 people said they drink 3 cups. So these are the people in the survey. So if somebody says they drink no cups, you have to include this 0 in the range because it's part of the data. If nobody drank no cups, then you wouldn't include the 0 in part of the range because there's no data there. So be careful when you get zeros at the beginning and the end. Now the range here, the highest one was 4, the lowest one was 0, so the range equals 4 cups. The mode is the most common. So what you do, you look down the frequency column and you see the most common answer was answered by 8 people, which is 0. So the mode is 0 cups. Now the median is the middle value. Now before we did n plus 1 divided by 2 to find out the position. We don't really need to be that accurate for these. So is a much simpler way. So just add up all the frequency, which is 8, 14, 19, 21, 23, is it? No, it's got to be an even number, hasn't it? 14, 19, 21, 22. So 22. So the 22 people all together in our survey. So all we do to find the median, which is the middle value, just divide it by 2 and we got 11. And that gives us our position. If you did the n plus 1 divided by 2, it'd be 11 and a half, but it doesn't make any difference, yeah? So what you do is you count from the top till you get to the middle, which is the 11th count. So we've got 1, 2, 3, 4, 5, 6, 7, 8 in there, 9, 10, 11. So it's in this one. So you'd go from this square here to the left to see it's 1 cup. So the median is 1 cup. 1 cup. And the mean. Now the mean, we need to find out, first of all, how many people there are in the survey. We know this. And we also need to find out how many cups of tea were drunk. And if we divide the tea by the people, we'll find out how many they drunk as a mean average. So this is where this third column comes along. So we've got total. And what we do is 8 people drank 0 cups of tea, so that is 0 in a total. 6 people drank 1 cup of tea each, so that's 6. We're just multiplying these two together. That's 10, that's 6, and that's 1. Just multiply those two numbers together. So now we need to add all these up, which is 6, 16, 22, 20. That's 4, isn't it? What am I doing? Yeah. 10, 26. 26 cups. So the mean is going to be 26 cups of tea divided by 22 people, and that's about 1.18. Yeah. So 1.18 cups each. Okay, now we'll move on to the other little bit, which is, as I said, as I hinted, this is stuff that we measure. So we are going to do the height, and this is called a grouped frequency table. Alright, a grouped frequency table. So we do the height and we did the frequency, and now remember that we couldn't do individual heights. We're going to have to group them together, and yeah, we're going to group them into this sort of thing: the small, the middle, and the tall. Yeah, so we're going to get everybody in, no matter what they are. So now don't worry about, we've got two columns on the right that are printed in the exam but not labeled. So what do we do with these? First of all, let's find out how we did this grouping. Now 1.4 and the height and 1.6. So we've got everybody between 1.4 and 1.6, and in the middle we've got everybody who has a height, H for height, of there, and 1.8 and 2.0. Now, so all the width, as it were, 0.2, of the different categories, the different groups, are exactly the same. They have to be, to make it reasonable to understand. Now, the problem here is if we have 1.6 and 1.6 and somebody comes along and is exactly 1.6, then we don't know which one to put them in. So we employ our old favourites, greater than, less than. So anybody who's more than 1.4 but less than or equal to 1.6 will go in this one. And there, these signs just repeat themselves, and these are already pre-done in the question paper. And now the question paper is going to ask us to find the range, the mode, the median, and the mean. It might only ask you to find out the mean if you're lucky, but if you're not, you've got to find all of them. Now the range is the difference between, let's put some numbers in here, because if there were nobody that was between that, then we wouldn't count that number. So we'll put some numbers in here. Now the range is the difference between the smallest and the largest numbers we can see in our table. I know you have to be bigger than 1.4 for there, but if you were 1.41, you'd round it down to that number 1.4 anyway. So the range is going to be 2 minus 1.4, which equals 0.6 meters. Now, the mode is the most common. So look for the biggest number in the frequency column, go to the left, and that is what the mode is. So it's 1.6, and just copy exactly what's down in here. It doesn't matter what it is, 1.6 to 1.8. Now the median we know is the middle, so we have to add up all these, 10, 16, 24, 34 in fact, don't know, 34, 10, 20, 34, yeah? So there's the total people that we measured, 34. So for the median, just do 34 divided by 2 equals 17. So that again is our lovely position. So we count 17 down. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It wouldn't be till we got to 27 that we drop into the next one. So 17 is in this box, and to the left it is this. So the mode, the median, sorry, is 1.6 H 1.8. You can put an M on the end if you want to, I don't know. Yeah. So there's the median. Now the mean. Now the mean, we need to know the number of people, which we've got, and we need to know their total heights. Now, because these 10 people are somewhere between these, we never know exactly how high they are. So you will always see this word in the question, and you know it's a grouped frequency table. You can see anyway because it just doesn't look like the other one. So this now is called the midpoint, because we're just going to take an average of the 1.4 to 1.6, and the middle of that is 1.5, the middle of that is 1.7, and the middle of that is 1.9. Now we need to multiply the frequency, how many, by the midpoint, by the average of those heights, and that's 15, that's 27.2, and that's 15.2. Add them all up, 57.4. So the mean is now 57.4 divided by 34, which is equal to 1.69 meters. Yeah, okay. Need to do another one. That's one of everything that we did in that lesson. I'll do the scatter graphs in another part.